Welcome back to the Deep Dive. It is Wednesday, January 21st, 2026. And if you've been doom scrolling the tech headlines lately, or just, trying to keep your head above water in this industry, the landscape isn't just shifting, it's practically liquefying under our feet.
That is a vivid image.
Oh.
A little terrifying, but yeah, pretty accurate.
Well, it feels that way, doesn't it? We usually sit here and we try to compartmentalize things. We'll do a deep dive on the latest LLM, then we do a separate one on the metaverse, and maybe, another one on crypto or distributed computing.
Right, we treat them like separate silos.
Exactly. But today, looking at the stack of research you've brought in, I feel like we need to smash those silos. We really have to.
We absolutely have to, because the sources we're covering today aren't about one specific gadget or, one specific app. They are about a convergence. A collision, really.
A collision of what?
We're seeing a collision between a completely new way for AI to think, and I mean structurally changing its internal thought process, and a completely new way for the internet to remember and secure data.
And just to set the stakes here for you, for the listener, we aren't talking about a faster database or a slightly wittier chatbot. We are talking about a fundamental shift from silicon-based logic, which is rigid and centralized, to something that looks a lot more like biology.
It really does.
Yeah.
It's organic. The deeper you get into these white papers, the more you see terms borrowed from nature. You see things like neural pathways, cellular signaling, immune systems. It's all over the documentation.
So, okay, let's lay out the map for today's deep dive. We have a monster stack of sources. I mean, it's a big one. We've got academic papers on a framework called BRAID, which is claiming to fix a fundamental flaw in how AI reasons.
A huge flaw, yeah. And then we have launch details for something called OpenServ, which is totally changing how we think about managing AI workforces.
And then we get into the heavy plumbing, the infrastructure.
Yes. We have technical deep dives into Holochain, the Oasis protocol, and something called the Star API. It's a lot to unpack.
It is. But to make sure we don't get lost in all the abstraction, we also have some really wild, real-world applications to ground all this. We're looking at a gaming project called Our World that gamifies saving the planet.
Sounds a little out there, but the tech is solid. And on the other end of the spectrum, some legitimately life-or-death scenarios involving healthcare IoT. We're talking about pacemakers.
Wow. Okay. So the mission today is to unpack this next-gen internet. And I hesitate to even use that term next-gen because usually that just means more expensive or slightly faster.
Sure, it's a buzzword.
But in this case, the sources really paint a picture of a tech stack that is efficient, fully autonomous, and oddly enough, designed to make you the actual owner of your digital life.
Which is a bold, bold claim. A lot of people have made that claim before.
And most have failed.
Right.
So let's start with the brain. If we're building this new digital organism, we have to understand how it thinks. We've got these papers on BRAID. Now, for the last few years, really since the GPT-4 days, we've been relying on something called chain of thought reasoning.
Right.
You know the drill? You prompt the AI, you say, let's think step by step, and it spits out a little essay before it gives you the final answer.
Right. And chain of thought, or COAT-AT, as it's called, was a massive breakthrough. I don't want to undersell it. It allowed models to tackle math problems and logic puzzles that, completely stumped earlier versions.
Absolutely.
But as we've scaled up, we've hit a wall, a hard wall. There is a massive hidden cost to chain of thought that the industry is finally reckoning with. The researchers in these papers, they refer to it as unstructured reasoning.
Unstructured reasoning. That sounds like a polite way of saying rambling.
It essentially is. I mean, think about how an LLM actually works. It's a probabilistic engine. It's just predicting the next word based on the last one. So when you tell it to think step by step, what it's really doing is generating a stream of consciousness in natural language.
It's writing a story about how it's solving the problem.
It's writing a paragraph. And the core problem, which BRAID highlights specifically, is something they call reasoning drift.
Reasoning drift. Is that like when I start telling a story at a dinner party and then halfway through I completely forget the point I was trying to make?
It's very, very similar. Because the model is writing in paragraphs, it gets verbose. It introduces what the paper calls linguistic noise, it adds filler words, or it over-explains a simple concept.
Padding out the word count.
And the more it talks, the more surface area there is for an error to creep in. It might hallucinate a small fact in the second sentence, and then use that hallucination as the basis for the third sentence. And by the end of the paragraph, it has confidently arrived at a completely wrong answer.
I see. So the thinking process itself is actually muddying the waters. It's introducing the potential for error.
Exactly.
Yeah.
And it's expensive. In 2026, we're all paying per token. So if your AI needs to write a 500-word essay just to figure out a simple logic problem, you are paying for every single one of those 500 words. For enterprise systems, that's just burning money.
It's totally unsustainable at scale.
Right. And this is where BRAID enters the picture. It stands for Bounded Reasoning for Autonomous Inference and Decisions.
Bounded reasoning. Okay, so we're putting guardrails on the AI's brain. Is that the idea?
Yeah, it's a bit more drastic than just guardrails. We're fundamentally changing the format of the thought itself.
What do you mean?
The BRAID framework argues that natural language, English, French, whatever, is actually a terrible medium for strict formal logic. It's just too ambiguous.
Right. A word can mean 5 different things.
So instead of letting the AI write a rambling essay, BRAID forces the AI to generate a mermaid diagram.
Okay, hold on. A mermaid diagram. Now, for the developers listening, they probably know exactly what that is. But for the rest of us, are we talking about sea creatures?
No, not at all. Mermaid is just a syntax for code that creates charts and graphs. Think of it as a really simple text-based way to describe a flu chart.
Oh.
So instead of writing, first I will calculate the cost of the apples, and then I will add the tax, and if the total is over $10, I will apply a discount, the AI generates a rigid code block.
Something like start node, arrow 2, calculate apples, arrow 2, add tax, arrow 2, a decision diamond, and then to an end node, that kind of thing.
Precisely. It's a symbolic deterministic graph.
Yeah.
It strips away all the, I think maybe we should, and it seems that the next step is, and leaves only the pure logic structure.
I get the clarity argument, but why does that matter so much for the cost? I mean, you still have to generate the diagram. That still costs tokens, right?
It does, but this is where it gets really clever. This leads us to what the research calls the golden quadrant of efficiency, and this is an economic breakthrough as much as it is a technical one.
Okay.
The BRAID framework splits the work into 2 distinct phases.
Yeah.
You have the generator and you have the solver.
2 different AIs, 2 different brains.
Exactly.
Yeah.
You use a giant model, something massive, high IQ and expensive like a GPT-5 medium or even a GPT-4o.
Yeah.
And you use it once to generate that logic diagram.
Yeah.
Smart Brain draws the map.
Okay, that makes sense. You get the expert architect to draw the blueprints.
But once you have the map, that mermaid diagram, you don't need the genius architect to lay every single brick. You can hand that flowchart to a nano model, a tiny, cheap, incredibly fast model that might even run locally on your own device.
And the nano model, it doesn't need to be smart enough to figure out the problem from scratch.
It doesn't need to reason at all. It just needs to follow instructions. It's an executor. It looks at the graph. Step 1, add these 2 numbers. It does it.
Yeah.
Step 2, compare the result to 10. It does it. It's all execution, not ideation.
That is, that's actually brilliant. It reminds me of Restaurant Kitchen.
Yeah.
The executive chef, she designs the menu and writes the recipes.
Right.
But you don't pay the executive chef to chop every single onion during the dinner rush. You have line cooks for that who are fast and efficient.
That's the perfect analogy. And the savings they're reporting are astronomical. The source material cites a 74-fold improvement in cost effectiveness on certain math tasks.
74-fold, not 74%, 74 times cheaper.
Exactly, 74 times. And up to 30x on procedural tasks. It turns reasoning into a measurable performance cost function. It stops AI from being this, magical ghost in the machine that we just hope gets the answer right.
Yeah, where we're just crossing our finger.
And turns it into an engineering problem that we can actually optimize. You can literally measure the cost of a thought and then work to make it cheaper. It's a game changer.
So, okay, we've upgraded the brain. We've moved from these rambling internal monologues to structured, efficient flowcharts. But a brain in a jar doesn't get much done. We need a body, we need a workforce, and that, I assume, brings us to OpenServ.
This is the next layer up, the organizational layer. If BRAID gives us smarter, cheaper thinking, OpenServ tells us how to organize and deploy that thinking. The sources describe this as a major paradigm shift, from driver assistance to autonomous with exceptions.
Let's unpack that phrase, because autonomous is a word that gets thrown around a lot. How is this different from me just using ChatGPT on my computer right now?
Well, think about your current workflow. You sit at the computer, you type a prompt, the AI gives you an answer, you read it, you realize it's not quite right, so you type a correction. You are the driver. You're constantly micromanaging the steering wheel. The AI is just It's the GPS or maybe the lane assist.
Right, I'm doing all the heavy lifting of context management and goal setting.
OpenServ argues that this model just doesn't scale. It can't. If you want to run a fully automated business or a complex system, you can't be sitting there prompting every single step. Autonomous with exceptions means you act like a manager, not a driver.
So I give it a high-level goal.
You assign a goal to an AI agent. That agent goes off and works on its own.
It just goes into the dark and does the job.
It works autonomously. And it only bothers you. It only throws an exception if it's a wall. There's some kind of ambiguity, or it's missing a password, or it has to make a decision that actually requires human intuition.
So it's like a good employee. A good employee doesn't come and ask you how to open the spreadsheet program.
No.
They only send you a Slack message when the client asks for a huge refund that you didn't authorize.
That's it exactly. But here is the massive technical hurdle they had to overcome. Memory. If you have a swarm of these agents running around doing tasks for 100 different clients, how do they remember what they're supposed to be doing without getting confused? We all know LLMs have limited context windows.
And we know they tend to get muddled if you overload them with too much conflicting data.
Right. So OpenServ's solution is radical. And sounds wrong at first. It's statelessness by default.
Stateless. To me, that sounds like amnesia. If the agent is stateless, how does it know who I am or what I asked it to do 5 minutes ago?
It sounds counterintuitive, I know.
Yeah.
But think about like a clean room in a laboratory or a factory. Every single time an agent spins up to do a task, it is a fresh, blank worker. It has zero memory of the last job it did.
A clean slate every time.
Every single time. It enters the room and it pulls the specific context it needs for this one job from an external project-based memory via an API.
Oh, I see. So it's like it walks into the office, picks up the file folder for Product Alpha, instantly reads everything in it, does the work.
And then it puts the file back.
And when it leaves the room, it forgets everything it just read.
Wiped clean.
That actually makes a tremendous amount of sense for privacy and security.
It is absolutely crucial for privacy. The source material emphasizes this over and over. Everything that happens in a project stays in a project. Because the agent is stateless, there's basically no risk of cross-contamination of data.
So you don't have to worry that the AI agent who just optimized your competitor's marketing strategy is going to accidentally leak some of those keywords into your strategy?
Exactly, because that agent has been wiped clean. It has no memory of that other project. It's compartmentalization at the architectural level.
And the ecosystem they describe, this SRV ecosystem, seems to be built entirely around this idea. They talk about these three levers: build, launch, and run.
Right, it's a full stack for creating an automated company. You use the platform to build these specialized agents. You use their tokenization model to launch them, which is how you create value or, sell the agent services on a marketplace. And then you have the run phase, where teams of these agents operate collaboratively to get things done.
So we have the brain, which is BRAID, making thoughts cheap and structured. We have the workforce, which is OpenServ, organizing those thoughts into autonomous agents. But now we have to talk about where they live, because right now, if I build an AI agent, it lives on Amazon Web Services or Google Cloud. It's on a server somewhere.
And that is the ultimate bottleneck. That's the central point of failure. If we're really building a biological internet, we can't have it living in a handful of centralized server farms in Virginia or Oregon. And that brings us to part 3, the nervous system. That brings us to Holochain.
Now I have to stop you right there. Holochain. Every single time I hear that word chain, my brain immediately goes to crypto. I think blockchain. I think expensive gas fees and, burning down rainforests to mine Bitcoin.
And the sources are incredibly, almost aggressively emphatic about this. Holochain is not blockchain.
Okay. Convince me, what is the fundamental difference?
It all comes down to physics, really.
Right.
In a blockchain like Bitcoin or Ethereum, every single node in the network has to agree on the global state of the entire ledger at all times.
Global consensus.
Right. If Alice sends Bob 5 coins, the entire network has to stop everything, verify that transaction, and agree, yes, Alice sent Bob 5 coins before the next block can be formed.
Which is why it's so slow. It's like everyone has to check everyone else's homework all the time.
And it's why it doesn't scale. The white paper uses this really powerful analogy involving walking steps. It asks you to imagine trying to track the global state of everyone walking on Earth at this exact second.
Okay, I'm picturing it. Billions of people all moving.
It's estimated that roughly 500 million steps are taken every single second on this planet. Now imagine if, for every single step I took, I had to broadcast that to the entire world and then wait for everyone in China, India, and the US to agree, yes, he took a step, before I could take my next one.
We'd never move. The entire planet would be in gridlock.
It is physically impossible. The speed of light literally prevents it. Blockchain tries to freeze time to agree on a global state, and that's why it hits a hard ceiling on transactions per second. Holochain takes a completely different approach. It's trying to mimic biology. It shifts from consensus to consent.
Consent. Okay, how does that work in data terms?
Think about your own body. Your individual cells don't wait for a global signal from your brain to metabolize sugar. They act locally, based on local conditions.
Right, they just do their job.
In Holochain, if I take a step, my cells know it. I record it on my own local chain. They call it a source chain. It's like my personal private diary of my own actions.
So everyone has their own ledger. I have mine, you have yours.
You have your own ledger. Now, if I am interacting directly with you, let's say I'm sending you a message or a token, then we both need to verify that transaction. We cross-sign it, but we don't need the guy in China to agree. We just need to agree between the two of us. It's about maintaining integrity between the interacting parties.
That makes so much more sense. It's peer-to-peer integrity, not global surveillance. But, okay, if everyone just has their own little diary, how is it a network? How do we find each other or share public information?
That is where the DHT comes in, the distributed hash table.
Okay, DHT. I remember hash tables from the early days of file sharing, like Napster, BitTorrent, that kind of thing, right?
Exactly the same principle, just evolved. In Holochain, they use what they call a relaxed, agent-centric DHT. Think of it like gossip or like cellular signaling in your body. When I do something public-like, I post a message to a shared space, I push a little cryptographic proof of that data to the public network.
To the DHT.
But I don't push it to everyone. That'd be inefficient. I just push it to a random selection of my neighbors in the network, maybe 50 other nodes.
So the data is sharded. It's broken up and scattered across the network.
Correct. And this simple change leads to the geometry of certainty. This is a security breakthrough. In the old cloud model, the AWS model, you have a honeypot. All the valuable data is in one massive database on one server. If a hacker breaches that one wall, they get everything.
Right, like the big Equifax hack. One key turns the lock, and millions of records just spill out.
In Holochain, there is no honeypot. The data is sharded across thousands, maybe millions, of individual user devices. So to hack the network, you can't just breach one server. You would have to simultaneously find and hack thousands of individual encrypted devices at the exact same moment in time.
It's like trying to kill a swarm of bees by swatting one single bee. The swarm just doesn't care, it survives.
Exactly. It's immune system security, not fortress security. It's resilient by design.
Okay, so this is all incredible. We have this biological agent-centric infrastructure, but here comes the reality check. We still have the old internet. We still have Google and Facebook and Amazon. We still have Ethereum and Solana. We can't just flip a switch and delete the last 30 years of tech development.
No, of course not. And that's where the bridge comes in. The source material outlines something called Oasis, which stands for the Open, Advanced, Secure, Interoperable, Scalable System.
That is quite the acronym, a real mouthful.
It is. But you can just think of it as the universal API. It's a translator. Oasis is designed to sit on top of everything else. It can plug into Web2 databases like SQL. It can plug into Web3 blockchains. And of course, it plugs into Holochain.
So it's the glue that holds the old and new internet together.
It's the glue, but it's smart glue. The absolute killer feature here, according to the papers, is something called Auto-Failover, which they also brand as Hyperdrive.
Hyperdrive. Okay, now we're definitely getting into sci-fi territory. What does it do?
Imagine it's like a Waze or Google Maps for your data. Let's say you're running an application and you need to save a file. Oasis looks at all the available networks it's connected to. It sees that maybe the Ethereum network is super congested right now, and saving that file would cost $50 in gas fees.
Which happens all the time.
All the time. And maybe the Solana network is down for maintenance, which also happens. But Holochain is running fast, and it's essentially free.
So Oasis sees the traffic jam on those other networks.
And it automatically routes your data to the best performing path. It makes that decision based on lag, cost, and even the physical proximity of the nodes to you. And it does this in milliseconds. You, the user, or even the developer of the app, you don't have to manually switch networks. It just flows the path of least resistance.
That is huge for usability. I mean, one of the biggest problems with all the crypto and Web3 stuff is that you have to basically be a computer scientist just to use it. Oh, did you switch to the Polygon network? Did you remember to bridge your assets? It's a total nightmare for normal people.
Oasis makes all of that complexity invisible. It just works. And it enables this broader, much more ambitious vision mentioned in the sources, something they call unity consciousness.
Okay, I have to admit, when I first read Unity Consciousness in a tech white paper, my eyes rolled a little bit. It sounds a bit spiritual, a bit out there.
It does, I get it. It sounds very new age. But if you strip away the mysticism and just look at the architecture, what they're actually describing is the end of silos.
The end of walled gardens.
Exactly. Right now, your digital identity is completely fractured. You have a Google login, a Facebook login, a bank login, an Epic Games login. You are a different person in every single app.
And none of them talk to each other unless you explicitly let them spy on each other.
Oasis introduces the concept of the universal avatar. It's single sign-on for the entire internet. You own your own data graph, you own your history. And because Oasis connects everything, you can take your reputation, what they call your karma, from one application to another.
Karma. This was another one of those terms that jumped out at me. We aren't talking about what goes around comes around in a spiritual sense. We're talking about a data metric.
We'll get to the specifics of how karma works in the applications, but essentially, yes, it is a verifiable, cryptographically signed history of your actions that you own, not the platform you're on.
So let's ground all this theory. We have the brain, BRAID, the workforce, OpenServ, the nervous system, Holochain, and now the bridge, Oasis. What can we actually do with this incredible stack? The sources highlight a project called Our World.
Our World is fascinating because it's a direct philosophical challenge to the current gaming model. The paper describes it as a benevolent Pokemon Go, and it runs on something called the Star ODK. That's the Omniverse Developer Kit, which sits right on top of the Oasis protocol.
Benevolent Pokemon Go. So again, I'm walking around outside with my phone.
Yes. It's built on geolocation. You go out into the real world, into parks, into nature. But instead of just catching imaginary monsters for your own personal amusement, you engage with this karma system.
So how do I play? What's the gameplay loop?
You earn karma by doing measurably good deeds in the real world. The sources list things like picking up litter, using your phone to verify that a hiking trail is clean and accessible, or helping people in your local community.
Okay, but is this just, game points? Like, congratulations, you have 500 eco points, here's a little badge. Nobody really cares about that.
That's the absolute kicker. Because it's built on Oasis and Holochain, this karma isn't just stuck inside the game. It is a portable reputation currency that's visible across the entire ecosystem.
So you're saying if I'm a high-status helper in our world, that reputation could theoretically unlock trust or features in a completely different app, like a financial app?
That's the idea.
Yeah.
It changes the entire incentive structure of the internet. It's an attempt to replace the ad-driven model, where the goal is just to keep your eyes glued to the screen so they can sell you soap, with a model that actually rewards you for healing the planet.
And because it's running on Holochain.
The Niantic or Google or Facebook doesn't own your location history.
Yeah.
You do. The record of where you walked and what you did lives on your source chain, on your own device. It's digital twin technology. Our world is the AR twin of Earth, but without the surveillance capitalism baked in.
I love the gaming example, but the sources also have something much heavier, much more serious, the healthcare IoT section. This part actually gave me chills. They bring up the WannaCry ransomware attack from years ago.
That was a pivotal, terrifying moment. For listeners who don't remember, WannaCry hit the NHS, the National Health Service in the UK. It locked up MRI scanners. It crippled entire hospitals. And why? Because the hospital network was a centralized fortress. Once the hackers found one crack in the wall, they got inside and locked everything.
And now, in 2026, we have pacemakers, insulin pumps, continuous heart monitors, all connected to the internet.
And the vulnerability is horrifying. There have been public demonstrations of so-called battery draining attacks. If a hacker can communicate with a pacemaker, they don't even need to stop the heart directly. They can just force the device to work overtime, verify unnecessary signals over and over, and drain the battery in days instead of years.
Which would require emergency surgery to fix. I mean, that is literally life-threatening.
So how does this new tech stack fix it? Well, it goes right back to the geometry of certainty we talked about with Holochain. In a Holochain-based healthcare network, there is no central server to hack.
There's no master key that unlocks all the devices.
There is no master key. The patient's personal health data and the device's own instructions set live on their own source chain. For a hacker to attack my pacemaker, they can't just breach the hospital's Wi-Fi and run a script on the network. They would have to physically find and crack the unique encryption of my specific device.
It just changes the economics of the attack. Hacking one specific pacemaker is incredibly hard. Hacking a million of them one by one is practically impossible.
Exactly. And for the devices themselves, which are often low power, the source mentions they can use lightweight cryptography, things like Simon ciphers. Because the Pacemaker doesn't have to waste its limited battery power helping the entire network reach global consensus like in blockchain. It can use that precious energy for what actually matters, keeping the patient alive and securing its own local connection.
It's amazing how consistent the theme is through all of these different sources. Whether it's the AI brain drawing a flowchart or the global network sharding data, the move is always away from big and central to small, distributed, and efficient.
That really is the core synthesis. Look at the pattern. BRAID takes a massive, monolithic thought process and it breaks it down into small, structured, verifiable steps. OpenServ takes a monolithic job and breaks it down into small, autonomous, stateless agents. Holochain takes a monolithic global ledger and breaks it down into individual sovereign source chains.
It feels like the internet is finally starting to grow up. It's stopping to just scream for attention, and it's starting to organize itself more like a living thing.
It's becoming resilient. A forest is more resilient than a monoculture tree farm. A distributed network is more resilient than a mainframe. And an AI that thinks in clear, logical diagrams is more reliable and resilient than one that just rambles in poetry.
But I have to ask the uncomfortable question, and this is really where I want to leave our listeners today to mull this over. We've painted this incredible picture of a world where you own your data, you own your AI agents, you own your digital identity.
The whole CEO of your own digital life concept.
Right, but have you ever met a CEO? They are stressed out. They work 80 hours a week. They're constantly managing things. If I become the CEO of my digital life, does that mean I suddenly have to manage all this? Do I have to personally manage my encryption keys and audit my AI agents and check the integrity of my source chain?
That is the danger. That is the precipice we are standing on right now.
Because if the technology isn't completely, totally invisible.
If it's not invisible, it will fail.
Yeah.
We don't want to become the IT support for our own existence. We just want to live our lives.
IT support for our own existence. That is a terrifying thought to end on, but a necessary one. If these developers, the ones building Oasis and Holochain and OpenServ, if they don't get the user experience right and hide all this complexity, we're just trading one set of problems for another.
Let's just hope they value user experience as much as they clearly value cryptography and decentralization.
Indeed. Well, that wraps up our deep dive into the biological internet. We went from AI flowcharts to swarm intelligence to saving the world with an AR game.
It's a brave new world out there.
It certainly is. And for you listening, don't just browse the web today. Think about the architecture that's running underneath it. Think about who owns the state of your data and where it lives.
Keep asking those hard questions.